The last part of this lecture is really a trailer for a topic I will talk about more in the next lecture. Whenever we try to measure anything, there is a possibility that we may make a mistake or a measurement error. That may be as simple as misclassifying a goat as a sheep, as in this cartoon, or vice versa. Errors are inevitable, but it's desirable to try and control them, and that requires us to understand a little about their sources and their consequences. A helpful way to think about this is to consider the following equation for a measured value. A measured value is what you see or record. It's what ends up in your data set. We can, however, break this down conceptually. Let's imagine that it's sensible to think of the thing that you're trying to measure as having a true value corresponding to the true underlying state of affairs. It might be as simple as assuming that there really are sheep or goats, or slightly more tendentiously, that people have a true position on an underlying and unobserved attitudinal dimension. This true, or as it's sometimes called, platonic value, is what we're trying to get at. However, there are sources of error that get in the way. Firstly, there are sources of error that we can reasonably regard as essentially random, in the sense that they are as likely to act in one direction as in the other. In the context of responding to a social survey question, momentary inattention or distraction is unlikely to favour giving one type of response rather than another type of response, so we could probably expect that sort of mechanism to produce errors that are purely random. Naturally, we would prefer not to have our data contaminated by any sort of error, but we can, to a degree, live with purely random errors. If they do not systematically favour one sort of reply or another, then they should on average cancel out. Much more concerning are the type of errors that we call bias. Bias in a measure occurs when it captures systematically something other than the thing that you want it to measure. It's well known that if in a social survey you present people with a long list of statements they're invited to either agree or disagree with, a certain proportion of them will agree, or will be found to agree with all items, and a proportion of these will do so not because they genuinely do agree, but because they're bored with the task, and saying yes is the quickest way to get through it. If something like this occurs, then measurement is confounded with a psychological predisposition to take cognitive shortcuts. A similar kind of phenomena may be found when asking people about even quite mildly controversial subjects. If there is a perception that some responses are socially desirable, then those who are most concerned to present themselves in a good light will have a tendency to give the socially desired response. Recall difficulty may also produce bias when measurement requires remembering events from some time ago. It's well established that if people are required to report the duration of past episodes of unemployment, some tend to forget about episodes of short duration. Unlike random errors, bias will not cancel out, and therefore it is a much more serious source of worry.